Good morning. Hello.
Yes, sir. Hello. Hello. Sir, voice cut out. Sir, voice cut అవుతుంది. హలో.
Oh,
సార్ చెప్పండి సార్.
screen visible ఉందా?
ఎస్ సార్, స్క్రీన్ విజిబుల్ ఉంది. సార్ ఒకటి డౌట్ వచ్చింది సార్. అది మీరు చెప్పారు కదా సార్, దిస్ కీవర్డ్లో సూపర్ క్లాస్ కీవర్డ్ని వాడలేము, సారీ సూపర్ క్లాస్ మెథడ్లో దిస్ కీవర్డ్ని వాడలేము అని ఎక్సెంప్షన్ ఒకటి ఉంటుంది. అది అది ఒకసారి చెప్తారా సార్, అది ఎలా అంటే ఎందుకు వాడలేము అని?
This keyword cannot be used.
ఇన్ సూపర్ క్లాస్ సార్. While you are saying about this keyword, you had mentioned like this keyword cannot be used in the superclass method. There is an exemption for this keyword.
Class method చేయకూడదని కాదు. It is not that you can use super class. Use a super keyword, this keyword, static members. Use this keyword.
Okay. Static that.
Static members topic discuss చేసినప్పుడు అప్పుడు చెప్పాం ఏమని, you cannot use this keyword or final or any other keywords, super keyword కానీ this keyword కానీ యూజ్ చేయలేము స్టాటిక్ మెంబర్స్ అని చెప్పుకున్నాం. అది దట్ ఈస్ డిఫరెంట్. ఇన్హెరిటెన్స్ లో we didn't use this keyword but we can use అని చెప్పా, right? We can use this keyword also in inheritance. Say for example you are defining class A and you have two instance variables B A B like this. Then you can create a constructor or you can create a normal method. Here if you give A comma int B like this, then you can use this keyword, this dot A is equal to A, this dot B is equal to B. You can use this keyword. Not use this keyword only when you use static member. If this variable is a static variable A B like this, then for this we cannot use this keyword, because static variable is only one in copy. It will be used by all the objects that are created. It will be shared by all the objects that are created for the class. But whereas instance variables, they will be available exclusively for each of the members. So if I create two objects for this class A, first object will have its own copy of AB and second object will have its own copy of AB. So we can use this keyword to refer to that particular object's copy of that instance variable. But when you use static variable, if you make this a static variable, because these variables will be shared by all the objects. If n number of objects are created, then all the n objects will be sharing the same one copy of this AB. In that case, if you use this keyword, it is not going to refer to that particular object's variable, right? So we cannot use this keyword for static variable because it is only one in number. If there are multiple in number, then we can use this keyword. But static variable is only one in copy, so we cannot use this keyword there. And even super keyword also. Super keyword we have used it in inheritance, right? So if you have a static variable in super class, then for that static variable you cannot use this super keyword to refer to that one, to any hidden variables or like, right? So hidden variables will be different. The static members will not be considered. So you can have class B extends A and you can directly use some other x comma y. You can use anywhere. Here also you can use void seed. int x comma int y. Here also you can use this keyword. X dot x is equal to x dot y. X dot y is equal to y. So you can create like this. There is no issue in creating. Work fine. This keyword will work fine.
Okay, sir.
Now, actually, we are supposed to deal with abstract classes, right? Yesterday, I introduced you what is an abstract class. What is an abstract class? Any class that has only at least one non-concrete method or abstract method. So I told you yesterday what is a concrete method and what is an abstract. A concrete method is one which does not have, which has a complete body and its implementation. That means the open brace and closed brace. Okay. So like this is an example of a concrete method. It has a return type, method name, and parentheses opened and closed with no parameters. It has a body. The brace is opened and closed. It has at least one statement, right? So in this method, what you're doing, you're displaying this is a concrete method. This such methods are called as concrete methods. But look at this method. Return type is there, void. Method name call me. Parentheses opened and closed, ending with a semicolon. This is an example of abstract method. So such methods must be qualified with the keyword abstract. And if you observe, class A, this is containing two methods. First method is call me, second method is call me too. Right? Even though there are two methods, only one of them is abstract method. Even if one of the method is abstract method, you must qualify the class in which that method is defined also as abstract. So this is mandatory. These are the rules that we discussed yesterday. Right? You must qualify the method first with the abstract keyword, and then qualify the class also in which this method is defined also as abstract. Right? So it doesn't mean that because you made this class abstract, all the methods in that class must be abstract. If at least one method, or even if all the methods are abstract also, we have to use the same abstract keyword here. Right? ఒక మెథడ్ కనీసం ఒక్క మెథడ్ అయినా అబ్స్ట్రాక్ట్ అయి ఉంటే ఆ క్లాస్ ని మొత్తం కూడా అబ్స్ట్రాక్ట్ అని డిఫైన్ చేయాలి. సో దిస్ ఈస్ హౌ యూ క్రియేట్ అన్ అబ్స్ట్రాక్ట్ క్లాస్. Then what is the purpose of this abstract method without any implementation or without any body? It is useless. Even if I create an object and call this will not do any work for me. So what is the actual purpose of a method? A method is used for performing a particular operation when it is called. But will this call me method perform any operation for me now? It doesn't have any body or implementation, right? It is useless. So what we need to do is we need to define its implementation, the subclass for this class A. In whichever class you define this call me, for that you must create a subclass, and in that subclass you must you must give the implementation for this call me method. So now look at this class B. So I created a subclass for class A, right? But I declared this class B also as an abstract because B is an abstract subclass for A. It must definitely give the implementation for call me method. But is this class B giving implementation for call me method? So because it is not giving implementation for call me method, then I must make this class also as an abstract class, right? Then if this class is made abstract, then we must define again one more subclass for this class B, because this is also an abstract class. So I'm creating a class C extends B, and then here I'm defining this call me method. So because I defined that call me method here, I gave implementation for this call me method here, I need not make this as an abstract. So you can take this to any level. So now if you don't want to define call me method inside this C class also, then make this C class also an abstract, and then define another class, say D, and make it subclass for C, and at least do it there. But it is meaningless going extending it to so many levels, right? So always we uh, define the method in the subclass.
Sir, hello. Sir, if we define the voice call me in the class B, then abstract keyword will not be used, no sir.
No, it will not be used. Only when you
Only
only when you don't define this, then you have to use the keyword abstract for this class. If I
okay,
define it here, then there is no need of using abstract here.
only
And
reason we mentioned abstract because we are extending to the next level. That's the reason we mentioned abstract here, no sir.
we are extending, and also we are not defining this call me method here, right? See, it is just like uh, if you are unable to do a particular, if your father couldn't achieve some task in his lifetime, so he'll expect at least his son or his daughter, whoever it is, to achieve that feat. And even if they are not able to achieve it, they'll expect their uh, children to do that, right? So when this is carrying to generations ahead, what will we say? Will we say the parents, the grandparents have been successful in achieving their feat or not? They didn't. They are not successful. But whenever the children does, will say that they are successful. So in the same way, when class A is not successful in giving the implementation or body for the call me, we have to call it as unsuccessful. That unsuccessful meaning here is nothing but abstract. Then we'll expect class B, the immediate child of class A, to do that for it. But is the class B successful in giving the implementation for call me? No, even it is not also successful. So that's why we'll qualify this class B also as an abstract, right? And then we defined a child for class B, and this child was successful in giving implementation for call me. So that's why we don't say that it is abstract. So we can extend it in that way till any level, but it is not suggested always to do so, because if you extend to many levels, the program will become complex, and even the user he himself will have some confusion. So unless it is necessary, we don't do that way, right? Then what is the purpose of this abstract class? Why we should uh, give this method an abstract, make this method an abstract without giving any implementation to it? Because in some applications, when you're writing program, you may not know exactly what this method is going to do at the time of giving the definition for this method. But later somewhere, when you create a subclass for it, there you may want to give a different implementation, right? And if I create another subclass for A without other than B, if I want to create another subclass D, there also I can use this call me method and give its implementation. I may use this implementation in different way. In class B, I may use call me to perform something, and in class D, I may use it for performing some different activity. So in that case, if I don't give this implementation in the superclass, but I give it in the subclass, but the subclasses have different implementation for these methods, then without giving any definition, if you leave this definition here and give it in the subclasses, then that will be useful, right? So that is the purpose of abstract classes. Say, for example, I'll write you here. I'll copy paste the same program, but make little changes to this program. So I'll make class C. And this also extends C. So what type of inheritance is this one? I'll remove this abstract first. So now look at this class. Class A is abstract because it has an abstract method call me, and it has a concrete method also call me too, right? Coming to class B, it is made a subclass for class A. When class B is a subclass for A, then it must definitely give the definition for call me. If it is not giving, then we need to qualify this class B also as abstract. But I'm giving the definition, right? Similarly, I created another class C, and this is also extending class A. So what is the meaning of it? Even class C also must implement this abstract method and give it a definition. So I've given definition for call me in C also. So that's why I didn't qualify class C also as abstract. But look at the call me version in the subclass B and call me version in subclass C. Are they both same? This is displaying a different message, B's implementation of call me, and this is displaying a different message, C's implementation of call me. So what do you understand from this? Why I am not giving the definition for call me in superclass here? Because even if I give some definition here, the definition will not be useful for class B, because class B want to have a different implementation than that what I give here in this class A, right? And similarly, class C also want to have a different version, which is not there in class B or class A. So in that case, is it useful giving a definition here in class A? Even though this class A is giving a definition here, and that is inherited to class B as well as class C, but class B and class C, they don't want that definition, they want a different definition, right? So in that case, what I can do is I'll leave the definition here. I'm not going to give the implementation or definition or body to this call me method. Instead, I'll make it as an abstract method. So I leave it to B, class B and class C. Whatever definition they want to give, they can give their own definition for that. So then call me method inside B is defined to display a message, B's implementation of call me, and C is displaying C's implementation of call me, its own implementation, right? So that is the advantage of abstract methods and abstract classes. So now that you understood what is the advantage of in which situation you can use these abstract methods and abstract classes, when the superclass does not have exactly a proper idea what the implementation of a particular method is going to be, then we can make that method an abstract without giving any implementation or body for it, and ask the subclasses for that class to give their own implementation whatever they like, right? So it is just like a parent has two children. He wants to give the same gift to both the children, but they don't want the same gift. They want different because their mindsets are different, their tastes are different. So they want a different gifts. They don't want the same gift given to their sibling, right? Then what we can do, the father or the parent, what they'll do is they'll not choose the gift for them. Instead, they'll ask them to choose their own gift and give it to them. So it is also the same way. Right? The call me method is an abstract method in the parent class. It is not given any implementation or body for it, and will allow the subclasses, child classes, to choose their own implementation. B choose its own implementation, and C also chooses its own implementation. Right? That is the advantage. Now that you understood this advantage, let us go back to this previous program and read this important point here. Already we have discussed these points yesterday. Any class that contains one or more abstract method must also be declared as abstract, right? So if in a class, if at least there is one abstract method, then that class must be declared as abstract. To declare a class abstract, you simply use the abstract keyword in front of the class keyword at the beginning of the class declaration. And there can be no objects of an abstract class. That means what, you cannot create an object for an abstract class. So now for this class here, I cannot create an object. That is, what is the meaning of that? That is, an abstract class cannot be directly instantiated with new operator. Such objects would be useless because an abstract class is not fully defined. Also, you cannot declare abstract constructors. So because this is an abstract class, now for this class here, you cannot create a constructor, right? You cannot create a constructor. Okay. Even abstract static methods also cannot be defined. So in abstract class, if you want to create an abstract static method, that will not be allowed, right? So in abstract classes, the restriction is that you cannot define a constructor, you cannot define an abstract method. Any subclass of an abstract class must either implement all of the abstract methods in the superclass or be declared abstract itself. So what is the meaning of this important point? Last point is, any subclass. You take subclass of A, that is B. What this must do, it must either implement all the abstract methods of this superclass A. How many abstract methods are there? There is only one method in this example. So this must implement that method, or else that also must be declared as abstract. So this is what mentioned. Any subclass of an abstract class must either implement all of the abstract methods in the superclass or be declared abstract itself. Itself means the class which is subclass for that abstract class, right? So it must either define all the abstract methods or it must be declared abstract. So these are the rules you need to follow when you are using abstract classes and methods in your program, right? So now that you have understood this, we have defined class A, which has two methods. One is abstract method, the other one is concrete method. Concrete method is displaying a message. This is a concrete method. Then we created a subclass B for class A. Because this class B is not giving any implementation to this call me abstract method, I qualified this class B also as abstract. Then I created a subclass because this is now made an abstract class. We must definitely create a subclass for class B and give the implementation of call me method, right? It is like hereditary. from grandfather has given the responsibility to the father, but father couldn't do that, so father gave the responsibility to son, right? Now son took the responsibility and he is defining the call me method, which is not done by his parent B. So that's why we qualify this as abstract, and now class C is not qualified as abstract because it is taking the responsibility and giving the implementation of call me. So till here it is over. Now how to invoke these methods? I'm creating an abstract demo class in which I'm defining the main method. I'm not creating object for class A or class B because both these are abstract classes. I'm creating an object for class C, right? And using C, I'm calling call me method and call me to method. So both methods I'm calling. The first one is abstract method and second one is concrete method. But even though it is abstract method, it was given uh, implementation in C class. So that's why now you can call it, right? So let me compile this program. Right? So C is implementation of call me. This is a concrete method. So this is what we have in those two methods. This is concrete method and this is abstract method. And C's implementation of abstract method is displayed. Right. So now if I remove this comment for A, creating object for A, and compile it, so I'll get an error. What is the error? A is abstract, cannot be instantiated. Right. Similarly, if I use it for B also, B is abstract, cannot be instantiated. Right. So this is what we mentioned at the beginning. There can be no objects of an abstract class. That is, an abstract class cannot be directly instantiated with a new operator. Such objects would be useless because an abstract class is not fully defined. Right. So if I put this in common, then now I'll be able to compile it. So remember an important point: any abstract class cannot be instantiated. That means you cannot create an object for an abstract class. Fine. And look at this, some more points here. Notice that no objects of class A are declared in the program. As mentioned, it is not possible to instantiate an abstract class. One other point is class A implements a concrete method called call me to. This is perfectly acceptable. Abstract classes can include as much implementation as they see fit. That means what? Even though the class A is an abstract class, right? It doesn't mean that class A cannot have concrete methods like this. Because it is an abstract class, you don't think that we must create only abstract methods here, but it will be allowed to create concrete methods also. Apart from the abstract methods, we can also use concrete methods also. So that is fine. But you cannot call this method directly by using an object of class A because you cannot create an object for class A. You will have a subclass, and for that you have created an object. So using that subclass object only, you are going to call that concrete method. Right. So this is an important point. People, normally students, what they do is because they think that this is an abstract class and an abstract method is there here. So we will not be able to create concrete methods in a abstract class. That is not right. Even though it is an abstract class, it is permitted to have concrete methods like this. Right? And look at class B. I didn't define any method here, not even any method. It only gets all the methods that are part of class A. That means an abstract method call me will be there, and uh, call me to concrete method also will be there. Right? So this is useless having a class here. You can have, if you want, you can create another class say here, void. Any
సార్ హలో హలో
hello.
సార్ ఇక్కడ వాయిడ్ కాల్ ఒకసారి క్లాస్ బి చూపిస్తారు సార్ వాయిడ్ కాల్ మీ టు అండ్ అది కూడా కాల్ మీ టు అని సేమే ఉంది కదా సార్
Yeah, అదే ఇప్పుడు ఏమవుతుంది చెప్పు.
అప్పుడు సూపర్ కీవర్డ్ యూజ్ చేయాలి కదా సార్ అంటే ఇండిరెక్ట్ ముందర
Not
క్లాస్
you will not get any error, but
అది
class version will be hidden. హైడ్ అవుతుంది కాబట్టి అప్పుడు దాన్ని కావాలనుకుంటే సూపర్ కీవర్డ్ యూజ్ చేయాలి. దాన్ని అవసరం లేదనుకుంటే సూపర్ కీవర్డ్ యూజ్ చేయాల్సిన అవసరం లేదు. నౌ ఐ వాంట్ both of them to be called, then I have to use super dot
సూపర్
call me to.
కాల్ మీ
నాకు అది అవసరం లేకపోతే అవసరం లేదు. అందుకనే కదా ఇప్పుడు దిస్ ఈజ్ ఏ కాంక్రీట్ మెథడ్ అనేది అవుట్పుట్ లో రాలేదు. దిస్ ఈజ్ ఏ కాంక్రీట్ మెథడ్ ఆఫ్ బి అని వస్తుంది. రైట్? సో ఇది ఓవర్ రైడింగ్ అవుతుంది. సూపర్ క్లాస్ లో ఉన్న మెథడ్ ని సబ్ క్లాస్ లో ఉన్న మెథడ్ ఓవర్ రైడ్ చేస్తుంది. If you want the superclass version to be called, then you have to use this one. If you don't want that, then you need not use it. It is not mandatory. But if it is a constructor, it is mandatory. Constructor లో అయితే సూపర్ కీవర్డ్ యూజ్ చేసి సూపర్ క్లాస్ కన్స్ట్రక్టర్ ని ఇన్వోక్ చేయడం ఇట్ ఈస్ మ్యాండేటరీ. బట్ invoking the superclass hidden overridden method is not mandatory. If it is required for us in our program, then we can call it. But we must provide a mechanism if at all if user requires that method, how to access it. So that mechanism we need to provide to the user. So that's why we give this opportunity by using the super keyword to call the overridden method call me. But it doesn't mean that it must be mandatorily called. If it is mandatory, then it will generate an error, right? So it didn't generate any error for me, right? So it is only not giving any output. It is not just calling this call me to method. It is only calling this call me to method. That's it. But if I want this also to be called, then I have to use super keyword. That is what we discussed, right? What is the purpose of super keyword? First purpose is to invoke the superclass constructor. Second purpose is to invoke access the hidden variables of superclass. Right? We are saying hidden variables, but we are not saying that this is going to generate an error. Similarly, third purpose is access the or call the or invoke the hidden methods of superclass. But we are not saying that if you don't invoke them, you are going to get an error. We are only saying that hidden why? Because you are having same method with same type signature in subclass. This is going to hide the superclass. So to overcome that problem of hiding and bring into limelight the superclass version of that method, so that also will be used. we are going to use super keyword. That's it. But it is not mandatory to use. You can put, you may or may not use. If you require, you will use. If you don't require, you will not use. Right? If I use it, then I'll get both the outputs. Right? C's implementation of call me. This is a concrete method which is defined in class A, and this is a concrete method of B. Right? Subclass. Fine. So now you can also add methods, some more methods to abstract class, some more method class A, and some more methods to class B also. It is not mandatory that abstract class will have only abstract methods. You can have both abstract methods as well as concrete method. But to make a class abstract, at least one of those methods must be abstract. That is the rule, right? Hope you understood this concept.
Yes, sir.
Fine. So now look at this program. I'm creating a class called figure and making it as abstract, right? Now I'm using dimension 1, dimension 2 declared as double. Then a constructor is created. For this I'm passing double A, double B, right? And then I'm creating a method, area method, which is an abstract. Then I'm creating a rectangle and making this rectangle a subclass for figure. So now what I must do in this rectangle class, because I didn't make this class rectangle as abstract, I must define or I must give the definition for this area method in figure class, rectangle class. So in rectangle, I'm creating a constructor and using super to call the superclass, because we cannot instantiate abstract class figure. So this constructor cannot be called by creating an object for class figure. So definitely what we need to do, we need to call that constructor using super keyword in subclass rectangle, right? So this is what we discussed in the previous program. So a class figure, an abstract class cannot have a constructor instantiated, because it cannot be instantiated. We cannot have a constructor. But if you give a constructor's definition, that can be invoked using subclass constructor by using super keyword like this, right? Then I'm giving the definition for this abstract method double area. I'm giving a definition here. So what is this double area going to do? It is going to display a message inside area for rectangle, and this is going to return dimension 1 into dimension 2. Means what? Dimension 1 is nothing but this one, these two values. These are inherited from superclass to class rectangle, right? And they are initialized by the constructor of the superclass, because we have invoked super a comma b. So for this rectangle constructor, when object is created, we are going to pass two parameters a, b, and those two parameters we are directly passing them to constructor figure. So they will be initialized for dimension 1 and dimension 2 variables. Then using those dimensions 1 and 2, I am calculating the area of the rectangle. Dimension 1 is nothing but length, dimension 2 is nothing but breadth, right? Why I use dimension 1, dimension 2 of length and breadth, I'll tell you later. After I complete this, you must understand. If you don't understand, then I'll tell you. So then I'm creating another class called triangle, and this is also subclass for the abstract class figure. So what is the meaning of this one? Even in this triangle class also, I must give the implementation for area method. So I have given it here, right? Then triangle also has a constructor. This also receives two parameters, just like rectangle. and those two parameters are passed again to superclass. So to initialize dimension 1 and dimension 2. Now coming to the area method definition, it is displaying a message inside areas for triangle. Then this is returning dimension 1 into dimension 2 divided by 2. So this is triangle. So because the area of a triangle is half into base into height, right? So dimension 1 is base and dimension 2 is height. Now I hope you understood why I am using dimension 1 and dimension 2, right? Why? Because both triangle and rectangle will have two dimensions. In case of rectangle, those dimensions are called as length and breadth, whereas in case of triangle, they are called as base and height. So their names are different. So if you create them here is length and breadth variables here, it will be applicable for rectangle, but when coming to triangle, those names will not be applicable for triangle because their names have to be changed as base and height if when coming to triangle. So instead of doing that, let us have a generic name dimension 1 and dimension 2. In case of rectangle, we'll consider dimension 1 as length and dimension 2 as breadth. In case of triangle, we'll consider dimension 1 as base and dimension 2 as height. Okay, so this is calculating area of triangle. So now you can understand, right? When an abstract class is created and the area method, right, it is not giving any definition because uh, it doesn't know what exactly will be the implementation for this area method in its subclass rectangle and in its subclass triangle. Rectangle wants its definition to be like this. It wants to calculate length of the area of the rectangle. So for which the formula is different. So it will have a different set of statement. Similarly, triangle's area will have a different statement. It is going to calculate a different formula, right? So that's the reason why we didn't give definition for area in superclass figure, right? And made it as abstract. And coming to subclass rectangle, we are giving a different implementation for it by calculating the length area of the rectangle. And triangle, we are giving another different uh, implementation by calculating the area of the triangle and returning that value, right? Now I'm creating abstract areas class, defining main method inside it. So I cannot instantiate, right? Because a figure is a abstract class, so I cannot create an object for this one. So I cannot instantiate by calling the constructor like this. Fine. So that's why I put this in comment, and here beside it I also mentioned in a comment illegal now. But I can create objects for both rectangle and triangle, right? So I'm creating rectangle and passing 9 comma 5. So this 9 5 will be assigned to dimension 1 and dimension 2. So now dimension 1 will have 9, dimension 2 will have 5. So they will be considered as length and breadth. Similarly, triangle I am passing 10 and 8. So 10 will be considered as base and 8 will be considered as height. But look at this one. What I am doing is I am not instantiating the class figure, but I am creating a reference variable. So what is the reference variable? We have discussed earlier at the time of creating, at the time of classes and objects concept, when I introduced you classes and object concept. Creating an object for a class is a two-step process. The first step, we create a reference variable. Right? And in second step, we instantiate the reference variable to make it an object. So what is the meaning of creating a reference variable? When a reference variable is created, it will be created like this. How? Class name followed by object name. Even though we are saying this is an object name, this is just a reference variable because it is not instantiated by using the new operator. And we are not going to call the constructor also. So this up to here it will be permitted for any class, even if it is abstract class also it is permitted. But the second step is not permitted for abstract class. For normal classes, we can do both the steps, but for abstract class, we can do only up to here, right? So what is that we mentioned in the previous program? There can be no objects. And when do you call it as an object? When a reference variable is instantiated, that is the second step is completed, then only we can call it as an object. Until then, we'll call it only using the name reference variable, right? So there can be no objects of an abstract class. That is, an abstract class cannot be directly instantiated with new operator, right? So the second step is not permitted for the abstract class, but the first step is permitted. So that means creating a reference variable is permitted or allowed. So I'm creating a reference variable for the class figure. So what is that reference variable? 5G Okay, because this is okay because no object is created. This is only a reference variable. So now for this reference variable, I can assign a subclass object. I can assign a rectangle subclass object or triangle subclass object. So first I'm assigning a rectangle subclass object. Then I'm printing area of rectangle is concatenated with, I'm calling the area method, but using which object? Figure reference, that is a reference variable for figure class, right? Then after that I'm assigning p and then making a call to area method using the same. So now even though we are we are using the reference variable figure which is of type figure class, because we have assigned an object of subclass rectangle, this will now act like an object of rectangle only. It will not act as object of figure class. It will act as object of rectangle class. After that, when you assigned t to that, this will now act as an object of triangle class, not rectangle or figure, right? So you can do this. This is permitted. When you use abstract classes, you can create a reference variable and assign that reference variable an object of its subclass and use this reference variable as an object of a subclass only to invoke the methods of subclass. So that is what I am doing. So I am using this figure reference variable as an object of rectangle and calling that area method of rectangle class. Similarly, here I am calling area method of triangle class. Because, but before doing that, you need to assign that reference variable with the object of that subclass. So I have done that in both the cases. Here I have assigned the rectangle subclass object and then displayed this message and then call the area method for rectangle. Then after that I'm modifying that figure reference variable to a triangle object and then displaying this message and making a call to the area method of triangle object. So this will work fine. This program will work and give you the output properly. Me- Right. So what is the output? Inside area for rectangle, area of rectangle is 45. Inside area for triangle, area of triangle is 40. We have given 9 and 5 for rectangle as parameters. So length into breadth is 9 into 5, 45. And for triangle, we have given 10 and 8. So 10 is base and 8 is height. 10 into 8 is 80 divided by 2. Area is base into height by 2, right? So 80 by 2 is 40. So the area of triangle is 40. Okay. So now let me discuss some points here that are mentioned at the beginning. Although abstract classes cannot be used to instantiate objects, they can be used to create object references, right? Because Java's approach to runtime polymorphism is implemented through the use of superclass references. Thus, it must be possible to create a reference to an abstract class so that it can be used to point to a subclass object. We will see this feature put to use in this example below, right? So what is the meaning of this? Already I told you, but only one point we need to discuss is Java's approach to runtime polymorphism. So what is polymorphism in Java? Ability to exist in multiple forms, right? So inheritance is one example, and sorry, not inheritance. Overloading is example of one example of polymorphism. Polymorphism means what? One of the features of object-oriented programming language. Because Java is an object-oriented programming language, polymorphism is one of the features of Java programming. So how this polymorphism is implemented means one example for polymorphism in Java is overloading. Overloading. What is overloading? You can have multiple methods with same name. Right? So the same method has different forms. It has one form where it is going to do one particular operation. It has another form where it is going to perform another operation. So we have done that in our programs earlier, right? So we have defined multiple methods with same name but with different type signatures or with different number of parameters and type of parameters. Even we have discussed it in yesterday's class also. But their implementation is different. The operation performed by both those methods are different, right? So, what is the meaning of that one? Those methods are existing in multiple forms. So, ability to exist in multiple forms is nothing but polymorphism. So, overloading is nothing but one kind of polymorphism, right? But that overloading is done during compilation. That polymorphism is done during compilation. So, when you compile your program, your compiler of Java will check whether there are two different versions of that method created in the class. If they are available, it will check it during compilation only. If they are not available, it will generate an error for you, right? So because that polymorphism is checked during compilation, we call that as compile time polymorphism. Overloading is an example of compile time polymorphism. But coming to this abstract references, creating these abstract references, whether you have assigned a reference variable figref of figure class with a rectangle class object or triangle class object, that is not going to be checked during compilation. And even if you create a reference variable here, this is not going to generate an error for you during compilation, right? So this polymorphism is implemented during runtime. So now this figure reference variable figref is having multiple forms. In this case, it is acting as an object for uh, rectangle subclass, and in this case, it is acting as object for triangle subclass. In other words, we can say that this reference variable is pointing to the object R in this case, and here it is pointing to object T in this case. Right? So that is what mentioned here. Though we cannot create a object for instantiate abstract classes, they can be used to create object references, right? Thus, it must be possible to create a reference to an abstract class so that it can be used to point to a subclass object. So, pointing to subclass object means what? If we assign a object of subclass to the reference variable of superclass, we say that the superclass reference variable is pointing to the subclass object, right? So, in this case here, figure reference variable is referring to or pointing to subclass object R. So which subclass object? Rectangle subclass. And here in this case, it is pointing to triangle subclass object T. So it is existing in multiple forms, which is nothing but polymorphism. But this polymorphism will be achieved during runtime. This is not going to be done during compilation. So that's why we call this as runtime polymorphism. So Java's approach to runtime polymorphism is implemented through the uses of superclass references. So how is polymorphism, runtime polymorphism implemented in Java means what? By using superclass references. So a superclass can be a abstract class or even a non-abstract class also. You can create a reference variable for that class. Even in the previous programs that we have created, even though we didn't use abstract classes there, they are concrete classes. That means they don't have abstract methods, right? So even in that case also, I can create a reference variable for superclass and assign a object of subclass to it and use that object to invoke the subclass methods or variables, right? So this is an approach used by Java programming to implement runtime polymorphism. Why we are saying this is runtime polymorphism and we are calling overloading as compile time polymorphism? Why? Because the overloading is checked during compilation whether it is implemented properly or not, right? But here this polymorphism is checked during runtime whether it is implemented properly or not. That's why we call this as runtime polymorphism. Okay, hope you understood.
Yes, sir. Hello. Hello.
So this is about abstract classes and how to use reference variables of abstract classes to make them point to objects of subclasses through which we implement Java's runtime polymorphism. So with this, we'll complete abstract classes. So in the next class, we are going to see another new topic. Fine. So we'll leave for today.
Okay, sir.